Good morning, Sam.
Hi, Sam. So these magnets, whether they're repelling each other like this, or whether I flip them over and they're all touching the thing, weigh 127 grams. It doesn't matter how they're oriented. The weight still registers even though it's lifted up. But if I actually lift it and hold it with my own, then it stops weighing it.
Ain't that neat?
So, yes, magnets weigh the same repelling or sitting on the thing.
That's Newton's third law, Sam.
So let's look at review
Is that
questions.
a chopstick?
Yeah, it is.
Whoa.
My favorite chopstick. Review questions.
Oh, really? Why is it your
Are you
favorite?
filming? Because we should probably film this first.
Yep,
Why
we're
is that one
filming.
your favorite?
Because it's green.
It looks cool.
Oh, I thought it would like had some like meaning towards it, like yeah, I got it from Ethiopia.
I've never actually been to Ethiopia.
Well, I haven't either.
I don't think they use chopsticks.
Shush. I was just coming up with the country.
Righto.
Ethiopia's not a country.
I got it from Luxembourg, you know.
I got it from
They probably
Chinatown in
make
New York.
chopsticks in Europe.
I went to Chinatown in Chicago and I was really scared. It was like,
Dead animals hanging.
yeah. No, not just only that. Like I thought that I was in another world. I was like, I don't understand anything that I'm hearing.
So remember what it's like when you're a minority, because for some people they're always a minority and it pretty much always feels that
Well,
way.
they're in America.
You were in America?
Yeah, you're right.
That is so true.
If I was in like
All right, keep
Mexico,
with us.
I would
Keep with
Did you
us.
see that?
learn Spanish.
You would learn, yes.
Yeah, I wouldn't just keep speaking.
The north pole of one magnet is put near the north pole of another. Do they attract or repel?
Repel.
They repel. North repels north. Here's labeled N. This is labeled N. You can see they repel. You can run it across the table. It's repelling. And now the north and south got together, so they're happy.
Are these like the mega magnets?
These aren't real strong. These two are really strong. Your neodymium, which I'm saying wrong undoubtedly, but you know. What is the significance or the direction, this is number 2, in which magnetic field lines point?
They always point north to south.
Start at the north, point to the south. So our next one is 2-bar magnets. And we've got a south here and a north here. And it only wants you to draw the field that's in there. So actually, it only wants you to draw the field that's in there. So what's our field look like in there?
Lines go from north to south.
Lines go from north to south. I'll change colors so it's easier to see. From north to south. From north to south. From north to south. If you actually want to see what magnetic field lines look like, then Josh will move his notebook.
I can't. I don't.
Is this yours?
Oh.
The red thing.
My arm
Oh,
hurts.
what's-
Oh,
Did I?
how did you?
Sorry. Will you point the camera at this? Alright, we're
Alright,
going
watch
to
this,
look
Sam.
at actual magnetic field lines.
Hey, we were playing with that, remember?
Alright, see? Here they go.
Wait, Liz. Who wrote Jordan?
Alright, so can you see?
Look at that, Sam.
See?
Ain't that neat?
See? Because I'm going to clean it up. See how the lines go?
That's so cool.
Lines. Yeah. Lines.
Oh, who wrote?
Y'all can get up and look if you want. 'Cause
Isn't that
I'm
cool?
going to clean it up because this would be
It's
a
really
real big
cool,
mess.
guys.
Whoa.
See?
Josh.
It's lines.
Ow.
Oh, that's really cool. Sorry, I didn't have my glasses on.
It made lines.
What if I
That's
blew
so
on
cool.
it? That would not be good.
How's it making the lines? What's
It doesn't
It's
do
a magnetic
anything.
field.
Don't blow hard, but
just from the earth, or is there a magnet?
no,
From
there's
the
a magnet.
magnet.
There's a bar magnet under there.
Oh, I was
You
gonna
can
say.
see the magnet as the density.
Oh, that's really
That
cool.
is really cool.
Wait,
It
can
looks
we
like
change the
ants
magnet
attacking.
underneath
Yeah.
and make the lines go a different way?
What happens if we put this little tiny
Can you
one
pull
there?
the? Ah!
That's.
All right, let's lower it.
Wait, here, pull it up a little bit so I can take the magnet off.
All right, I got my magnet off.
It's got a strong attraction.
Now it's all random.
It's still 80
So if you put the other magnet, what magnet do you have? Do you have one under?
I have
Oh,
this- just
little
this.
guy here. Well,
I
that's
bet
good.
this is like a big ripoff. They go to like a factory where they're like making axe heads and sweep the floor and dump it in there and then
Heaven,
charge you
somebody gave it to
$5
me.
for the jar.
Well, that doesn't
That's
work
a little
if it's
much.
too thick.
Where'd the magnet go?
It
Here.
won't come off then.
That's so funny.
Oh, 86.
All right, we'll go a little lighter this time.
It was looking good, but then you dumped some more on there. There, look at that.
Ah, that's so cool. That is so nifty. Wait, can you pour some more so that we can have more lines? Who wrote in the station?
Oh my gosh, look, this used to be a screw.
Oh,
Awesome.
T.S. Eliot was messed up.
what was wrong?
Ezra Pound messed up too.
Hey, is it okay if I like
Emotional.
Is it okay if you like text me all the
Alright.
answers or something?
So,
Though you will have to know who wrote the love song of J. Alfred Prufrock, which is
T.S.
the easiest question on that.
Who wrote The Raven? Edgar
Alright.
Allan Poe.
focus,
Who
focus.
wrote Night Journey?
All right. Number 4. What's the difference between a monopole and a dipole?
Dipole has negative and positive, like on both sides, and then a monopole only has one charge, but that's impossible for a magnet.
Yeah. Well, no.
You haven't
Theoretically,
found one.
mathematically, it's not impossible.
But we haven't
They haven't
found
like
one.
one that's just
Can't they
naturally
just
there.
construct one?
No,
It
because there's.
can't
Okay,
work.
if you chop a magnet in half,
It automatically
It-
becomes two magnets.
yeah.
Well, then how
Just
is
like
it
an earthworm.
mathematically possible?
I don't know. You'd have to ask Einstein.
Think of an
Not
earthworm.
smart.
If you chop an earthworm in
I will
half,
ask those
both
kinds of
halves will
questions.
grow
Right,
back into a whole worm.
beyond
It
the
won't just
scope
be
of
two
my
halves of a
thinking.
worm.
If you that a cockroach lives 7 days.
9
without its
days.
head,
Don't
Without
want
its
to hear
head.
anything about
Because it has an
bugs.
extra brain in its
And-
body.
and-
Already not feeling well today. Please don't talk about
and it
bugs.
dies after starving because it can't eat.
And that happened to a chicken once.
Is there
Wait,
any such
9
thing as an
days?
electric monopole?
No.
Yes.
Yes. What's an electric monopole?
A little electron,
An
like
electron.
a ion.
Or a proton or an ion? Something with an
One
actual
charge.
charge. Is there a magnetic monopole?
They haven't
No.
found
No.
one.
know of.
That we know.
What causes magnetism?
The flow of electrons.
Positive and negative.
Motion of electrons. Yeah, and it's actually really interesting. When we studied uniform circular motion, if you shoot an electron or a proton through a magnetic field, what happens is uniform circular motion. So, I don't know, I thought that was interesting. So just like we always set a force equal to the uniform circular motion, the mv squared over r equation, you can set the force, the EMF equation equal to the mv squared over r equation and solve for tons of extra stuff. It also doesn't matter about the mass of a charged particle moving through the magnetic field. It only just matters about the velocity, because mass cancels just like every other time we set mv squared over r equal to something else. So uniform circular motion and magnetism and electricity are all linked. In Newtonian physics, not calculus-based stuff like we study at non-relativistic speeds, magnetism and electricity are different, but at light speed, it's all the same. I don't understand any of that. But also we know that when you have a light wave, it's transverse, so it oscillates perpendicular to propagation. And we know that the electrical component oscillates and perpendicular to the magnetic component of light. So think of light wave going this way with the electricity
Light has
wave.
a magnetic component?
It's electromagnetic radiation. So light waves have a magnetic component perpendicular to an electric
How is
component
that possible
perpendicular
if
to
they're
motion.
not anything?
Hmm?
They're a wave.
Magnetism isn't
Particle.
anything either.
Well, we don't know. We know light behaves as a particle.
So
In
as a
some
particle, it's
instances.
attractive, it has magnetic.
But I guess when something's moving at light speed, I just don't understand how to do anything with understanding what it is.
But don't feel bad because the best scientists can't understand either, so.
Well, I'm not them and I have no clue, except that I can give you those very basic moments of information. Go
Oh, yeah,
to a professor
and-
with a doctorate for more information.
if you do happen to like swallow a magnet, don't go into like an MRI machine. Because it,
Yeah.
like,
Who would
there-
swallow a magnet?
well, like
Babies?
there was this like war veteran or something. He had like a piece of shrapnel in his body, and he was gonna get like an MRI image, but the magnet was so strong it ripped the shrapnel out of his body.
Oh, that's horrible.
Happy birthday to him.
You might want to
Hey,
did he die?
that if
I don't know.
Because shrapnel, I don't know if it would go like super far and
It
whatever.
depends on what part of your body it's in too.
Yes.
If
Like
it
it's in
cuts
your
a
leg
big
or something
artery.
like
I mean, all right. Well, let's go back to that
Thanks,
bug
Josh. You're the
discussion.
nicest person.
What
for
are the
telling us
3
that.
classifications of substances from a magnetic point of view? So something diamagnetic, and it's
Paramagnetic.
what does a diamagnetic substance look like?
Wood.
It's made up with no magnetic field.
No magnetic field. Is
So
that
it's like this
totally
drywall.
true?
No.
So what
No,
if
it just cancels out because like one little particle has positive and the other particle has negative, so it cancel out or something like.
that's paramagnetic, that the atoms have magnetic fields but they're misaligned so they cancel each other out?
Isn't
Oh, yeah,
diamagnetic just like it's such a teeny magnetic?
And no, it's just nothing.
The only time it does have its own field is if you bring a very powerful magnet near it. It actually exerts a very weak but opposite, not equal and opposite, but weak and opposite field. So like a piece of wood, for example, something that's not a conductor is usually diamagnetic. And if you bring a very strong magnet near it, it will actually it will develop an opposite but weak magnetic field.
Like even a piece of wood.
Apparently.
I feel like a
I
piece
just
of
can't
rubber.
imagine that.
Apparently. Now, I have no machines to measure this stuff,
I guess
so
it
I
would
have
be
to
like
take his
a
word for
very
that
strong
one.
magnet.
I know, like, mass spectroscopy, which is one of the things that I did as a chemist, is based on this. You shoot, vaporize and shoot, or liquidize, aerosolize something and shoot your sample through a magnetic field.
It's like that one
How did
table
you
that used to
do
be in
that?
the library.
With the
Remember that?
car!
Yeah.
Cars that you
I love
Yeah.
Only now they're
Oh,
lizards.
I used to do that in the they used to have the magnet ones where you drew the
Doctor's
pictures like
office?
at the doctor's office. Yeah.
Mhm.
I remember I was super
Germy,
sick and I
very
was like,
germy. That's why you don't want to touch anything at the doctor's office.
or you just get your mom to bring Lysol and just.
I sprayed Lysol in a bathroom one time, and some lady like ripped me apart. She was really nice. She's like, "I have asthma. You can't spray that." I'm like, "It's a bathroom. I can't not spray it." Whatever.
Probably already sprayed in here anyway.
I know, right? Like people don't clean the bathroom.
It's okay.
Oh.
One time my
Right?
granddad was spanking my dad and this woman came out and started screaming at him. She's like, "How would you like it if you were being spanked?" And my dad would turn and stop crying and was like, "Lady, what's wrong with her?" Some people are just crazy.
Even back then, somebody said something.
Yeah, some was-
No, back
Started
then I thought
screaming at my
that
dad
person
for
would
it.
help him out and be
I know, right?
like, "Let me help you out."
Wow. Yeah, I'm thinking.
What did your dad say?
My dad
Stop.
said that like anybody's mother would just grab you and spank you. Like when he was, if he's 82, and when he was a kid, you were fair game.
I would run away from random people trying to spank me. Ah!
So anyhow, so diamagnetic is non-magnetic basically. Paramagnetic is the next one. What does a paramagnetic substance look like, Nick?
What is what?
Paramagnetic. Yeah, where's your stuff? And Josh, what does paramagnetic stuff look like? What does Matt have to say about this?
What is that? He's like, I didn't do it, sorry.
What does Christina have to say?
I have it.
At least I
He
give you
has
my
a
test.
notebook.
It has no net magnetic field, but an outside substance can give it one.
Okay, so paramagnetic has no net magnetic field, but its atoms do have their own magnetic field, and magnetic fields are caused
So is that like a paperclip?
apparently, yes, by the movement of electrons. So, in paramagnetic substances, the electrons, their spin, which I didn't teach you guys in chemistry, I don't know if you've ever read about, but is arranged such that the electrons are arranged and numbered such that
It's making
they
it spin.
can exert a magnetic field, but they're misaligned. If you line them up by using electricity or a strong magnet or something, then they can align and have a magnetic field. Yes.
Can a paramagnetic substance that's like under the influence of a magnet, can it give another paramagnetic substance charge or a magnet?
It would probably be the magnet.
Like that.
Yes, it would just be the magnet that's doing it, though.
Oh, so it's not the
It's just-
paramagnetic.
The magnet is just aligning in both paper clips.
Oh, really?
Hooray! Do it in front of the camera. He's picking up paper clips. The paper clips are paramagnetic. They're not magnetic themselves, but under the influence of that magnet, their atoms line up, so their magnetic fields
Don't
are
have enough
aligned,
to do
and they
three.
actually do have a field at this point. But as soon as they get away from the magnet, they'll go back to not having a magnetic field of their own. And what's the last one, Stephanie?
What are we on?
Number like 7.
The ferromagnetic ones.
Ferromagnetic. And what does that look like?
They add.
Okay, so their fields are aligned, they're additive, so the thing is magnetic itself. This is what a permanent magnet is. But we all know that nothing is really all that permanently magnetic. You can bang it real hard. Don't drop magnets, that's one thing. It misaligns
So don't like
them a
throw
little
them
bit.
at.
Wait, really?
Yeah, I mean, I keep dropping these because I'm really clumsy, but
Did
it's
you-
bad for magnets to drop them.
Really?
Does it misalign?
Hey, remember those ones that like the kids play with that you throw up in the air and
Oh, the
they.
buzz.
Oh, yeah, and
I
they
have
go.
some of those here.
That's like hematite or something. I have some of those.
They're sitting right there, apparently. I mean,
Do you remember those
Where?
rocks that you
Oh,
could buy
these.
at the like when you would walk out of grocery stores or like stores and they're like black rocks and they all like come together?
Yes,
and
I
then
have
you-
some in my
yeah.
coat pocket.
Are those like
I don't have
magnets
my coat.
or are those rocks?
Oh, those
Or
are the
those
ones.
magnets?
Buzzers.
Now they actually,
Those are-
ladies, you might want to know,
Those are
they
so
actually
good.
sell
I can't make them
magnetic
like this.
beads now. So you, instead of putting
No,
the
they were
class on, you
seeing
can
them.
just string magnetic beads along
Oh,
with your regular
my
beads.
grandma has that.
That's cool.
Yes, that's a brilliant way to bead things because I hate clasps and I can't attach them right.
Wow, that's cool.
My grandma has a magnetic necklace.
That is
But
so
there-
weird. It's like all of a sudden like fell off your
There
neck.
are these things called lodestones that you dig right up out of the ground that are iron rock
It's just like,
things.
oh,
I just know
sorry,
that
my
at the store. They
magnet
sort of look like
necklace.
this, so maybe this
Yes.
is what they are.
I think they probably are, but I'm sure there's a way to fake it that's cheaper too, so who knows.
Oh, you just dropped it.
Do you know how
You
to do
ruined it.
No.
I don't know how to do it either, do you? I've had
I
those for
used-
3 years and nobody can make it work.
You have to like separate them, like with your finger or something,
Wait, that wasn't right. You have to get between like your fingers.
and then throw them up. There, yeah.
Oh.
You dropped it.
How did you do that?
Bounce.
You have to like put between your
Yeah, it was
fingers, or there's a specific way. Like
You have to
you go
throw
like
them.
Ah, that's cool.
You're the coolest.
Don't hit people with them.
you like put your thumb in.
Yeah, Nick is moving now.
First try.
Now I finally.
Wow.
My first try, they didn't even come back.
Oh, it sounded kind of cool. It was like,
That was a really good one. Oh my gosh, that sounded so cool.
Oh,
hey
dear.
Sam, are you hearing this?
Yeah.
sure
Oh,
he
he
is.
kinda
Sam,
saw
look,
it. Do it again. Do it
ready?
again.
I'm a professional.
Do it again.
That is funny.
That's how you do it.
My kids are going to be so happy
Is it
when they
told
get
you how to
home.
do it?
Alright, number 8. Why are some atoms magnetic and some aren't?
They must be arranged. The electrons inside must be arranged so that they're not like random. It's like in order. So that
Fields
they
have to line up
line up.
instead of being misaligned so they cancel each other. Number 9. Are all ferromagnetic substances permanent magnets?
No.
No,
No, why?
I don't know. I got it wrong though.
Because the
Yeah.
charges eventually go back to where they're positioned.
Oh
They
yeah,
might
like
not
if
be
you drop a
aligned.
magnet,
Can you make magnets not be able to be magnet?
drop it.
Yes, you can.
Just
You
roll
can
that
destroy
stuff.
the. I mean, if I hammered on these magnets, they would get.
They would get
weaker
all
because-
unaligned inside.
Number 10. A substance is not attracted to a very powerful magnet. What is it? Di, ferro, or
Diamagnetic.
para? Diamagnetic. A substance, number 11, is attracted to a weak magnet. Josh, what is it? If something's attracted to a weak magnet, is it magnetic or not magnetic?
Oh, it's still magnetic.
So is that diamagnetic, paramagnetic, or ferromagnetic?
Is it the D side?
No, that's something that's
What question
absolutely
is
not
this?
magnetic at all.
So it's pair.
Para is something that can become
Ferro.
magnetic under the influence
So the
of
F one, the
Ferro.
ferret one.
think ferro means iron in Latin. Like ferrous is like what people used to
you
call
said ferret.
ferrous.
Ferret.
Like that's what people used to call iron. Barium is why its chemical symbol is Fe. That's a
Oh,
Fe.
really?
Yeah.
Fun fact.
I'm like,
So-
you weren't even listening to
I was listening.
Number so I don't know what number I'm on. Number 11. If it's attracted to a weak magnet, it's ferromagnetic. Number 12. Nick, a substance is weakly attracted to a powerful magnet. Paramagnetic. Number 13. We're supposed to draw magnetic field lines for a current carrying wire. Oh, I meant to do something like this.
it. It's
Okay,
counterclockwise. Right?
No.
I was finished.
Okay, so if you have a wire and your current is going down, you use the right hand rule. So you point your thumb in the direction of the current, and then your hand goes whichever way your fingers point, which mine are pointing clockwise. So number 13, we have a clockwise field.
Oh, he says you can also do it with your left hand, but you have to follow the actual path of the current, not the conventional current.
Yeah.
You
So-
read so much, dude.
It's right here in the book.
Yes, he read the physics book this week like he was supposed to.
I read it sometimes, I just usually don't remember.
If instead of the right hand rule you do use the left hand rule, you're not using convention, you're doing the actual path of the electrons, so everything's backward but right. So, you know. Number 14, state Faraday's law of electromagnetic induction.
Oh, it's got something to do with.
The electromotive force in a loop of wire is
proportional to the rate of change in the
magnetic
flux.
flux through the loop.
So what's flux? I didn't quite get
Flux
that.
is the changing
It's like baby vomit or
magnetism.
something. Or wait, no,
Okay,
that's really
so,
like reflux or something.
flux, like if you look at this thing that I can't get to work at all, and maybe one of you will with our leftover time today, this is an electromagnet. So here's the magnet, here's coils of wires. If you spin, either if you spin a magnet or if you pass a magnet through a coil of wire, and I've always wanted to try this, I always forget. Where's my voltmeter? We'll see if it works.
They make like flashlights. Like it's like that. Instead of having a battery, it's got like a big piece. It's got like a magnet.
And you go
then
like
a bunch
this?
of coil. Yeah, and you shake
I
it.
have one of those.
I have one of
Yes, I
those
have
too.
one of those.
Only
They
like
don't work very well.
I think
Your
I-
arm gets
breaking.
tired. It's like a shake
yeah.
weight.
I think I dropped mine, so now something rattles inside it and it doesn't
Yes,
work.
but you could take it apart and play with it.
Well, it wasn't. It won't. Like it's like sealed shut. There's no screws or anything,
Oh.
so I can't figure out how
Really?
to open it.
Hacksaw.
Well, I
Okay,
don't want to like
so
ruin it in case I do fix it.
in
So-
case you fix it, we wouldn't want to ruin it.
They're probably like $10 each anyway. So
Oh, yeah.
I got mine at Home Science for cheap. With, I think it came free with my massive order because
that would be
obviously-
cheap.
Yeah. Okay, so if I wonder if we can do this. If y'all pay attention for half a second, you know.
Pay attention, everybody. Come on, Josh. Stop playing with those
'Cause
rocks.
We all want to watch me fail at one more experiment here, right?
Yay!
Okay, so what this is saying when you talk about flux is a changing so if you have a loop of wire, which I have here, I have it attached to a voltmeter just in case we actually manage to produce a voltage. And then I have a magnet, bar magnet, anybody?
It's under the bag.
Of course. And so there's a picture in your book of passing a magnet like this, which doesn't work at all, of course.
Where? Oh, in
Make
this.
sure we're filming this complete failure of. So if you spin, I don't know, maybe you guys can play with this after we are done talking, but it seems like what they're saying is if you, a current carrying wire, so we need a current in this wire, so we need a battery.
Or can we just like spin this thing?
I haven't had much luck with that thing. Okay, so if I have a current carrying wire, which I do if I push these guys in here, and then I stand this up and pass a magnet through it, Here, hold this on the sides of the battery. For Sam. Oh, thank you.
Hold on a tick, Sam.
I've always wanted to try this, and I should try it before class, but I wanted to go watch the TV show.
Hold these.
Yeah. And then I'll find the bar magnet. Alright. Oh, and I'll have to spin this one because it's like...
Oh, wait, 1 second.
Oh, okay. So we have a current carrying wire.
There, now Sam
So
can see.
this is what it's doing. It should, like, spinning a magnet through a current carrying wire should cause flux, but then I don't know how to tell if it did. Maybe
What
we
is
should
flux?
think this through a little. Well, it's the rate change of magnetism, right? The north-south thing. So, let me think a second. If you have a spinning magnet, then your flux is always changing, right? Because it depends on the sine of the angle. So, like, from 0 to 180 degrees, your magnet is going from, well, what's the sine of 0?
0.
And what's the sine of 180?
Negative 1.
Negative 1. 0.
0 minus negative 1.
Not minus. 0. So it changes from 0 to negative 1. And then from 180 to 360, where does it go?
360 is 0, and 180 is negative 1.
So you have a continuous change in your magnetism. That's flux. It's just like, you know, and it's called the electromotive force, but it's not actually a force. It's a voltage, a change of potential difference. So we should generate voltage by changing, is that thing still hooked up? No. We should generate voltage by passing a magnet through a current carrying wire, but I haven't actually figured out how to demonstrate this successfully yet. Maybe someday I will. Or maybe you guys will today. Yay! Because that would save me thinking. So let's look at number 15, because this is kind of...
Number 15.
Alright, so number 15, in which of the two situations would an ammeter read the largest current? Oh, we should set that up as an ammeter, not a voltmeter.
Is it B?
B, why?
Well, I looked at the equation. It said when the area, I think between of it is larger, the
Bigger area of loop is a bigger current.
yeah.
So you're just passing current carrying wire through a big loop, and that should generate current. We could try that. I suppose you guys can try that after we're done fooling around. And if anyone actually does anything successful, we need to write it down for me. Number 16, describe the energy conversion steps in a hydroelectric power plant.
I was always bad at this in chemistry. Because I never think of
I mark a lot wrong on
everything.
these because people miss. So where do you start with a hydroelectric power plant?
The river
Water.
or waterfall.
Okay, and what does it do?
It spins
It
like a
runs.
wheel with magnets on it,
Okay,
and then when it's spinning, it changes the flux,
right, spinning magnets have a
and the wire
continuously
coils
changing
create
flux.
electricity.
Okay, so you've got spinning magnets, wire coil, it makes electricity, which is what I'd really love for us to manage to do, but as of yet I haven't quite figured out how to actually put feet on the theory. Number 17, how does a wood burning plant turn its magnet?
Same thing basically, except for the water is steam and the wheel is a turbine.
Okay, so you burn the wood, heat the water, the steam turns a fan, and the fan turns the magnet instead of the wheel being turned physically by a river or waterfall. Number 18, what's the difference between direct current and alternating current?
Direct goes in one direction and alternating goes back and forth.
Right, and it's because of this flux thing. Oh, it should be the coastline. That's why I'm so confused.
Oh yes, then it would go from 1 to...
Negative 1.
Oh yeah, still negative.
Right, so flux as the magnet spins is going to continuously vary. So the alternating current that is made in power plants from a spinning magnet obviously has to alternate because the spinning magnet creates a continuously changing flux. Direct current from a battery is just electrons flowing, and of course they always flow from a negative to a positive, so they go one direction to get direct current from a, D cell battery or whatever. And number 19, I just said, does a battery power direct current or alternating?
Alternating.
No,
Direct.
A battery, just like the circuits we studied last time, just electrons flow from negative to positive on a battery. Number 20, in Europe, the standard electrical outlet produces alternating current that is 220 volts. Does that mean that its maximum potential, the maximum voltage, is 220?
No.
No. What is
It's average.
220? Average. 220 is the average.
So does that mean, like, if you stick a fork in the plug over there, it'll be even more dangerous?
I guess so, but,
You're lucky,
instead.
Josh, that you live in America.
Oh, it was a paper clip. I don't even know how I didn't die.
So their magnets basically spin slower.
They
in
used to
Europe.
have like the actual like switches to shut it off, and just in case someone did it.
Oh my gosh.
I can't believe I
I don't
did
know,
that. I was like in
okay.
3rd grade.
Yeah,
or
that's
something,
really
third,
not
fourth
good.
grade.
Really? There's still danger of a kid doing that at that age? Ugh.
Yeah.
Only for Josh.
Well,
When I was in public school, kids did not act like they were in 3rd grade. Like I look at my sister, and I'm like, when I was in your age, I did not. I was like so corrupt. In public
Matthew
school.
definitely is no, I mean, he's likely to stick a fork in an outlet, I suppose.
Who, your son?
Yes.
Matthew.
He's such a sweetie, but curious.
They're crazy. They're fighting with swords and stuff.
He has so much hyperactive energy.
Yeah, I had to go get my lunch because I left it at home, and I heard Jared and him like doing a battle or something.
All
like
he
that.
wants to do is just beat things up.
Ooh, I have this pocket knife that my dad had when he was a kid, and look at the blade, the back of the blade. It's
You don't want to
got like a
get that
little
on film.
thing taken out of it. So like he was trying to like cut a wire or something, and it was still plugged in or something, and he said he like heard a bang, and he watched like a little drop of metal fall off and roll all across the floor.
Uh-huh.
So it's
Oh
like a piece of the
my
blade is
gosh.
melted.
So here's the thing. CCT generally says that you're not supposed to have knives. So put that in your
Oh,
pocket.
whoops.
I didn't see it.
No, it's actually a screwdriver. See.
Excellent. A screwdriver is always useful. Calculators must have batteries changed at some time or another.
You're right.
When I
yeah.
was little, I was opening a pocket knife when I was really little.
You
It
sliced your
cut
hand
open my thumb.
Oh, wow.
Are you crying?
I put something, a brush bristle under my thumb now and
It's like
totally hurt it.
5.
I
Okay,
know.
so here's what I want.
Thank
Turn
you.
off the camera and Sam will show you if anything good